did number 3, your first step is I need to factor the denominator. So if factoring is what held you back on the skills test for polynomials, we're going to be practicing factoring the next 3 days. So if you want to retake your skills test Tuesday, your polynomial factoring skills should be good again. If you're looking for a whole, kind of a cheating way to factor is say, hey, I wonder if 2x minus 1 is a factor in the denominator. Well, if 2x minus 1 is a factor, what would your other factor have to be? You know that you're multiplying to get 2x squared minus 7x plus 3. So what would the other factor be if you already think you know one of the factors is 2x minus 1? It would be 2x times x, right? So this would have to be x. What would this term have to be over here? To get 3, it would have to be -1 times -3. Let's just check if that works with outer and inner. This would give you -6x, -1x. So yeah, that's -7x. So when you're looking for wholes, sometimes you can cheat a little bit and say, oh, I wonder if this is a factor. It is. So I cancel the 2x minus 1s. So now I just have the function 1 over x minus 3. So I'm going to do steps 1 through 4 over there on just this circled function. Then I'll come back to this and think about where the whole was in my function. But I should be able to answer all the questions about this function over here. So y-intercept, x-intercept, vertical asymptote, horizontal or slant. Can someone tell me what the y-intercept would be of this function, plugging in 0 for x? I'm plugging in 0 right there. What do I have left? Someone say it. -1/3. 0, -1/3. I plot right there. So there's my y-intercept. What's my x-intercept? So if I set the numerator equal to 0, can I do it? So in that case, there would be no x-intercept because this will never equal 0. It's always going to equal 1. So if there's no x value in the numerator, there's probably no x-intercept. What's my vertical asymptote? What makes the denominator undefined? 3. So x equals 3 is my vertical asymptote. So I'm going to dot in my vertical asymptote. Aiden, I gave you this, right? You have it, and Emily, you have it. Everyone has this set of notes. Okay. So my last step is I have to fight numerator against denominator. Who has the bigger degree? Numerator or denominator? Denominator wins, a linear function. I've got no x's in the numerator. Denominator wins. So over there, if the denominator wins and blows up real big, it's going to approach 0 because 1 divided by a billion is about 0. So y equals 0 is my horizontal, so I can dot that in. It's kind of hard to say, but. All right, so I know where this elbow goes. It goes through -1/3 and then shoots its way down like that. So there's one part of my graph. I need to figure out what's going on over here. So what would be a good value to plug into my function for x? What number would I plug in for x? I want to know what's going on over here. So give me an x value that's over here. 4, right? Because that's on the right side of this asymptote. So if I plug in 4, 4 minus 3 is 1. So 1. 1 divided by 1 is 1. So I know that 4, 1 is a point on my graph. So there's my other elbow. So I just plugged in an x value, figured out my y value. All right, my last step. I canceled this factor over here, right? So originally, this would have produced an undefined value if I plugged in 1/2, right? Because if I set this equal to 0, add 1 to the other side, divide by 2, 1/2 would have been my asymptote. So my whole is going to be at 1/2, comma something. I'm going to take 1/2 and plug it in up here into this function. So you might need a calculator for that. I'm going to take 1 and divide by 1/2 minus 3, right? Because I'm plugging in half for x. Subtracting 3, it's in the denominator. I put it in parentheses. Negative 0.4. So at 1/2, I have a hole right here at negative 0.4 on my graph, which means that that value is undefined. If I looked at this graph, if this was a calculator problem, tomorrow you're not going to have a calculator, so I'll give you ones that you could calculate without a calculator. But here's my graph. So it looks like I got it right. I can't see a hole on here, but if you go to your table at 1/2, wait a second. Oh, I didn't plug in the original function. The original function was 2x minus 1 divided by 2x squared minus 7x plus 3. So here's my function again. It looks the same. But now I can't see a hole on the graph, but if I go to my table says there's an error at 1/2. So I know that I got the hole correct. That's a lot of work for one graph. So that would be like one question on the quiz, and maybe I'd give you one other question on the quiz because you've got to go through those 4 steps. All right, so let's do number 4 together. Who can help me factor the numerator? How would I factor the numerator of this? Got to have your factoring skills. What strategy can I use? So pecking order, we should always look for greatest common factor, difference of squares, a trinomial, might be a diamond or a box, and then maybe one of our newer strategies, like we had cubic for the formula, we had that quadratic form, we had grouping. I'm not going to pick these more challenging ones, for the quiz, but maybe by the test I would pick one of those. So who can tell me how to factor this numerator? 5x squared minus 20. What do I do? Greatest common factor, yeah, which is what for this term? So 5 times x squared minus 4. Can I go a step further? This is now difference of squares. So I actually should write it as 5 times x plus 2x minus 2. I'm running out of room. So 5x plus 2x minus 2. So now my denominator kind of also has 2 steps. What could I factor out first as a greatest common factor? Can I take out a 3? I'd have x squared plus 4x plus 4 left, which is a little bit easier to factor. What does that trinomial factor into? So what are the factors of 4 that add up to 4? Yep, so 3x plus 2x plus 2. So one set of x plus 2 is going to cancel, right? So I have 5 times x minus 2 over 3 times x plus 2 that I'm going to answer all my questions about. Here's my winning reduced function. So that was a lot of polynomial work. Greatest common factor and difference of squares, greatest common factor and using that diamond method. You have to know those polynomial skills in this unit. All right, so now let's answer our questions together. I need a y-intercept, an x-intercept, a vertical asymptote, and a horizontal or slant. So I actually think doing the y-intercept would have been easier up here, but I had to cancel things. So I guess, yeah, we got to plug it in here. So I plug in 0, 5 times negative 2, right, would give me negative 10 over, plug in 0, 3 times 2 is 6. Negative 10 sixths. I have to plot that. What is that? Negative 5/3. And what's negative 5/3? Negative 1 2/3. 0, comma, negative 1 2/3. Just so I know where to put it on the axis. It'd be like here, right? Negative 5/3. That's right, right? Negative 1 2/3. Okay. All right, next up, x-intercept. I kind of keep them in this order because I plug in 0, then I look at the numerator, then I look at the denominator, then I compare the two. So it's kind of a logical progression of what you're looking at. So if you kind of memorize this order, it's kind of a cheat sheet of what to do next. All right, I'm looking at the numerator. Where's the numerator going to be 0? When x is 2, right? 2 minus 2 gives me 0. X-intercept is at 2. So plot 2 on the x-axis. Vertical asymptote. My next step is I just look at the denominator by itself. What's the bad value for me to plug in? -2, because -2 plus 2 gives me 0 in the denominator. So x equals -2 is where my vertical asymptote would go. So plug in 0, look at the numerator, look at the denominator, compare the two. Which is the winning power? Numerator or denominator? What would you say? Which of those three choices? Numerator wins, they tie, or denominator wins? You're looking at the powers, right? Linear, right? So they actually tie in powers. So when you strip the coefficients, it would be 5/3, right? So I have a horizontal at y equals 5/3, which is 1 2/3. So at 1 2/3, you've got your horizontal asymptote. Because if you plug in 1,000,000, you basically get 5 million divided by 3 million. These little -2s and +2s don't really affect 1,000,000, right? So here's my first little elbow. My other elbow is probably over here. What would be a good value to plug in to figure that out? If this is at -2, probably want to plug in like -3 for x. So if I plug in -3, let's see, -3 minus 2 is -5 times 5 would give me -25 up top. If I plug in -3 down here, I get what? -1 times 3 is -3. So this is going to give me a positive number, right? I don't know, 25 divided by 3 is, what's 8 times 3? 24. So it's about 3. Is it 3 1/3? 25 thirds. Is it 3 1/3? 25. Oh no, 8 1/3. 8 1/3, right? 8 1/3. So if I plug in -3, I'm at 8 1/3. So that's up here, 8 1/3. I mean, we really just do that to get what region of the graph we're in, right? Plug in an x value to get a y value. So that's a long problem without a calculator. So just each step, take your time on each step. It's really like 4 questions in one. Does this function have a hole? So I canceled this factor up here, x plus 2 over x plus 2. Where was that function undefined? Where would my hole be? What would have made that 0? -2. Does this function have a hole at -2? Well, see how this factor stuck around? So you actually had the same factor twice. You only canceled one of those factors, right? So we actually have an asymptote at -2. An asymptote is like more powerful than a hole. So I don't have a hole, I just have an asymptote still at -2. So I've already accounted for this undefined value because I have a whole asymptote right there. So there actually might not be a hole if there's like a repeated factor in the denominator. But you should always go back and just verify you found your hole. All right, let's do one more together. I want to do one that has, I want to do number 3. And then I'm going to have you kind of work through 1, 2, 4. Take a look at number 3, because number 3 is not written as a nice rational function. It's written as 2 separate fractions, basically. Remember, anything can be written over 1. Do you remember the process to combine 2 fractions? This is probably more of like a bonus. It wouldn't be on your quiz tomorrow. But how could I make this into one rational function? Do you remember the process? Like if you have, I don't know, if you have the fraction 2/3 and you want to add 11/6. Do you remember how to combine two fractions? What do you need? Common denominator. So what would I have to multiply this fraction by over here? 2/2. Remember you multiplied by 1, like 2/2 is 1. So this is really 4/6, and then you're adding 11/6, and you get 15/6. You don't add the denominators, right? It's like 2 apples plus 2 apples is 4 apples. So you don't add 6 plus 6, you just still have 6 at the end. So in this one, what would my common denominator be? It's actually going to be x plus 3. So you're going to multiply this fraction by x plus 3 over x plus 3. So this is just a good algebra skill, not a focus. I'm not going to, give you a really hard one like that, but this gives me what? Negative 5x minus 15 when I distribute that negative 5. So my new rational function is really negative 5x. And then I've got 1 over here, and I have negative 15. I'm adding them together, so minus 14 over x plus 3. Now that looks like a rational function that I could do something with. Right? I can answer all these questions. Some of you might recognize this from day 2 of virtual. I talked about simple transformations. That goes left 3, that goes down 5 of the original parent function 1 over x. But this is a way to get to what we've been practicing. So let's go through these questions together, and then I'm going to have you try 1, 2, and 4. What's my y-intercept? What is it? Plug in 0. There was nothing to cancel, right? So I don't have a hole this time. I'm just looking at a regular old rational function. Plug in 0. This x is gone. This x is gone. What are you left with? Yeah, so what is that? Negative 14 thirds would be negative, is it 4 2/3, I think? 14 thirds, so negative 4 2/3. Not great with improper fractions. All right, so negative 4 2/3 is my y-intercept. Negative 1, 2, 3, 4 2/3. Okay, so what's my x-intercept? So I just look at the numerator by itself. And if you can't do it in your head, actually take the numerator, which is negative 5x minus 14, and set it equal to 0 to write out the algebra. So what do you get when you solve for x? Add 14 to the other side. Divide by negative 5. So positive 14 over negative 5 is what? Negative 2 4/5. Negative 2 4/5. Right, because 10/5 would be 2, and I'd have 4 left over. Negative 2.8 is what that is, right? I think. All right, negative 2 4/5, somewhere right there. Somewhere between negative 2 and negative 3. So I got my point here on the x-axis and my point here on the y-axis. So I probably wouldn't pick this problem, right, for your quiz, because you're not going to have a calculator, so I'll pick something that's like nice, easy, whole numbers. All right, where's my vertical asymptote? Negative 3. So negative 3 is right here. All right, and here I'm looking at this function, the numerator and denominator tie. So what's my asymptote? My horizontal asymptote would be where? I have negative 5x as a coefficient and then positive 1x. So negative 5 divided by 1 is negative 5. So it's horizontal at y equals negative 5, which makes sense because then it's going to be right below where that y-intercept was. So I can kind of see how the elbow is forming. There's no hole. So need to figure out what region the other part of the graph is. If this is at negative 3, I probably want to plug in negative 4. I might just do this one with a calculator. So let's see. I'd have negative 5 times negative 4 minus 14 parentheses divided by, oh, the denominator is just going to be negative 1, right? Negative 1. Negative 6. So if I'm at negative 4, I'm at negative 6. So the other elbow would be down there. All right, what's my domain and range to finish this one before I have you try a couple on your own? So when I scan the x-axis, where's the only break in the x-axis? X cannot be what value? Negative 3. And when I scan the y-axis, what's the only break in the y-axis? Negative 5. So y cannot equal negative 5. So when I write an asymptote, I use the equal sign because it's a line. When I write domain and range, I write cannot equal because it cannot equal those values. All right, so before we go out for our walk, I'd like you to take a little bit of time and